Okay, another step once again in the transcended idea. Yeah, of course, to those who are watching our videos for the first time, we're really trying to help ourselves as well as others who are curious out there. Like you're just born with curiosity, this and that. Yeah, so like to help ourselves and one another to understand why we say, why I myself say, as well as others who believe this, say when you talk about geotropism, or in another ways that is called gravitropism, the response there, the the growth response in plants in respect to gravity as the stimulus, as the force behind the elongation of the roots, to be specific. But as we say no, we argue to that motion. Yeah, so it's so overwhelming that sometimes we treat the sometimes we treat physics and biology and maybe even chemistry like separate, as if they are not one family, but in the end they're just one family. So I find that there's a certain principle in physics that affects a certain explanation, a certain theory in biology. But because this one is called the science of life, this one is called the science of mechanics, we tend to separate them rather. Okay, so what we are doing here is we are going to try to help ourselves understand how the motion of an object moving through a medium is affected by the properties of that particular medium under which it is moving. So what we're using there is the drag force equation. The one there we're seeing Fd is drag force. We're seeing 1 over 2 there, which is half. This is the density. So density is simply the density of the material that you're using. It might be, in this case we say fluid, so it might be air or it might be liquid. Okay, then the Cd that we have here is the drag coefficient. So each shape has its own drag coefficient. An irregular shape has its own drag coefficient. A sphere has its own drag coefficient. Yes. Then what we have here, A, is the surface area of the object that you're using. Then what we have here is V2, which is the speed. Okay, so you can manipulate that and we make V the subject of the formula. Okay, so meaning in this case, V is going to represent how fast the object is going to go through a medium, or will it even go through that medium? How far will it go if it is going to go through that medium? So it might be under a certain force, or it might be under a free fall. Okay, so in this case what we have, I have a glass of water here. This is water, as you can see. This is dishwashing soap. It is much thicker than water. We say the viscosity of that one there, the dishwashing liquid there, is much greater compared to that of water. So earlier I was trying to use cooking oil, yeah, but I realized the cooking oil that we have is very light. So like of course, like you'd see a difference if you had to put the video in slow motion, but at least it really needs to be, the difference really needs to be visible. Yeah, and since the camera that I'm using is not like those advanced ones. Okay, so what we're going to do here is I'm going to put water in this other cup. Please pardon me, I don't have beakers, so I'm forced to use cups just here at home, and the good thing is that they are transparent. Yeah, this thing is very thick, huh? Okay, almost there. All right, so what we have here are two stones. I earlier wanted to use coins, but I realized as I drop the coin from this height and the other one simultaneously, maybe this one might turn the other way, and you find that if it enters this liquid just in this same position, the speed will be much greater. But in case if it had to turn like this, meaning you have increased the surface area, hence reducing the speed there. So at least I take something that is more of irregular than, yeah. So from there we're even able to at least see the formula making sense. So in this case, before I do the needful here, what you are seeing here, the density, the drag coefficient, and surface area. So when the surface area is greater, meaning the speed is going to reduce. When the density is greater, meaning the speed is going to reduce. But the mass, the gravity there, those things remain the same. Okay, so because when you talk about the solid ground, yeah, when you talk about the solid ground, I think we'd even like, it's more like we have this liquid here, we have that one that is thicker than this one, then here we have a solid ground. In which do we expect an object that is, for example, I say experiencing a free fall, in which of those three, in which one is it going to move faster than the other? And in the other one, will it even make any movement whatsoever? The answer will be no. Yeah, so here just trying to help, we just need to ask physics, we're just trying to use physics to help us understand why what happens, and how can it help us to understand some things. Yeah, so I'll drop these two stones simultaneously into both these cups. This one, this is as I said, dishwashing soap, and this is tap water. Okay, I'll not say pure water, I'll just say tap water. Okay, so there you have it. I'll try to play the video at last in slow motion so that we see in which medium did it move faster compared to the other. Then we'll be able to understand what that formula there means. Yes, and why under the transcended idea we say, okay, gravity, the force of gravity is very great, but it really has it has limits. Okay, it really has limits. It depends on the properties of that medium. So when you are talking about the roots going through the soil, going down in the soil, as they say, of course they are going in the soil, but it's not because they are influenced by gravity. That one is a misconception. I believe it's a misconception. Yeah. So those I've loved to use this explanation. It's more like I enter where I stay. I enter the house where I stay at the moment. I use the sitting room door instead of the kitchen room door. Then find that in between there's a dining room, and from the sitting room you're able to go to your bedroom, so on and so forth. So imagine like they have prepared a very nice dish, something that you really love to eat, like a favorite. Upon entering through the sitting room door, you smell that nice aroma, and you really want to know where that food is. Are you going to head towards your bedroom? The answer is no. You're going to head towards the kitchen because that's the place where food is prepared. So it's more like the roots, they go deep into the soil for them to explore the necessities of their growth and development, which are nutrients. It might be water, it might be a lot. There are just a lot there in the soil. Yes. So that's all from this video. Please don't forget to subscribe and ring the notification bell so that each time we upload something, you'll be the first one to be, yeah, you'll be the first one to know, to say, I think here something else interesting has come. So please, as you can see, you're not trying to use anything complicated. You don't have a big at home, don't worry. We have these drinking glass cups. Yeah, so yeah, that's it from this video. Thank you very much. Water.